Okay, question 7. I don't know how good my microphone is. I don't know if you can hear the music from my next door neighbours, which sounds very nice, but but not what I really need right now. So yeah, question 7. The cost of a journey with Tom's taxi um, depends on the distance travelled. The graph below shows the cost, which is p pounds, of a journey with Tom's taxis against distance travelled, which is d miles, and it's got 2 points. So there's a lot of information there we really don't need. Okay. What is important is we've got a straight line, okay? And we've got 2 points. So that's 0.814 and that's 0.1220, okay? Because miles is d, so d is x and p is y, okay? That's my x values, and that's my y values. Looks like I've drawn a pi symbol, doesn't it? Okay, x and y. So let's call this 0.1, we'll call this 0.2. So yeah, we don't really need to know. There's nothing here that's particularly, exciting. Even the points as well. Yeah, it's again they've got a good diagram and they've got data which we don't information we don't really need. Okay, so we need to find the equation of the line. So when you think equation of the line, there's two equations of the line you can use. Some people use the y minus b is equal to x minus a, which is totally fine. I am not going to use that. I prefer y is equal to mx plus c. Okay, so m's our gradient and c is the y-intercept. Okay, so see here, that's the y-intercept. Looks like it's going to be quite low. It's probably going to be about 2 or something like that. So yeah, I can right away I can think roughly what that's going to be. Gradient-wise, it's positive. Okay, if the line is going in this direction, that's positive. If it's going in this direction, that's negative. Okay. If it's a horizontal line, it's going to have a gradient of 0. If it is a vertical line, it will have an undefined gradient. Okay. So yeah, all lines that aren't these two extremes. So horizontal is going to be y equals something, and a vertical would be x equals something. But everything in between is going to be y equals mx plus c, because everything in between has got a gradient and will hit the y the y axis at some point. Okay. So yeah, I really like this layout. So to get the gradient, our equation is y2 minus y1 divided by x2 minus x1. It's very straightforward that. I mean, effectively all that's saying is if this is your line, okay, we're just looking for the difference in height divided by difference in length. Okay, so y2 minus y1 would be this part here, which is the height of the line, and then x2 minus x1 would just be how far it's travelled in this direction, and then we divide them. Simple as that. Okay, so if you can't always remember that, just think what you're doing. You're doing difference in height divided by difference in length. Okay, so let's work that through. So 20 minus 14, that's going to give us 6. And on the bottom, x2 minus x1, 12 minus 8 is going to give us 4. 6 divided by 4. They both divide by 2, so it's going to give us 3 over 2. Okay, so right away we've got our gradient. So we can now say y is equal to 3 over 2x plus c. Now how do we work out c? Well, we just substitute in x and y. We can use either point, but just substitute in. Let's use the smaller numbers because they're easier. Okay, so let's say 14 is equal to 3 over 2 times 8 plus c. So 3 times 8 is 24, divided by 2 is 12. So 14 is equal to 12 plus c, so therefore we know c is going to be equal to 2. I did that in my head. What I was really doing there was saying 14 take away 12, because here it's 12 plus, so to get it to that side, do the opposite, so it's 14 minus 12. So our equation is going to be y is equal to 3 over 2x plus 2, and again that makes sense, positive gradient. Okay, it's not wildly steep, it's quite close to 1, so that again that makes sense to me. And I did guess 2, if you look at the scale, it's probably that kind of number. So quite happy. The very last thing we need to do is just turn it into a relevant equation. Okay, so y is p, so p is equal to 3 divided by 2, and x is equal to d plus 2. Okay, so there's 3 parts to that. There's getting your gradient, getting your intercept, and then just turning it into the correct formula. Okay, now there's 3 marks available, and that is exactly what they're for. Okay, calculating the gradient, so we get a mark for doing a gradient, tick. Then we get a mark for substituting to the equation, yep. For us that's to get c, and then finally, in its simplest form, okay, so again if we left it in maybe 6/4 wouldn't have got us a mark. We need to simplify it down and put it into the correct terminology. Okay, good stuff. So now calculate the cost of a journey of 5 miles. So 1 mark, dead simple. This is just checking you understand what you've done. Now again, if you didn't get the first bit right, you can still get marks here. Just make up an equation, okay? Make up an M, make up a C, okay? P is equal to, and maybe make it slightly complicated just so you don't not get the marks. If you make it too easy, you wouldn't get the marks, okay? So, P is equal to 5/3d, plus 8. Okay, something like that's going to get you the marks here. So just make up an equation and just follow it through, and you'll still get a mark, okay? So P is equal to 3/2d plus 2. But the journey's 5, so we know that d is 5. Okay, so I'm just going to substitute that in for 5. See, times 5. So what does that give us? 15. 3 times 5 divided by 2, so that's 7.5 plus 2, so that's equal to 9.5. And we'll just make sure we do it in the right term. Now, again, if it's money, I would always just do it to 2 decimal places. I'm just going to check the marking scheme to see if they care about that. Do not penalise for the omission of pounds. It says do not accept 9.5. So that's where a lot of people would probably fall down here. They would forget that the question isn't an equation. We're looking for money. You would never say, oh, that was 9.5 pounds. Okay, so remember your 2 decimal places for your money. It's like if you get a time question, make sure you remember your AM and your PM. Okay, very important not to omit that. Okay, or do the 24-hour clock, but make sure you put it into the context it's saying. So that's an easy mark to be lost by putting 9.5 at the end there. Okay, so yeah, that would just be 1 mark, obviously. So, equation of a straight line, y is equal to mx plus c, m's your gradient, and c is where you cross the y-axis. If it crosses through the origin, that would obviously be 0, so you would just end up with y is equal to mx. Okay, but everywhere else you would have a c value. Okay, it could be a negative c value if it crosses the y-axis below the x-axis. If it crosses down here, that'd be like negative 2. Okay, but that always comes up. Really important to practice that. Okay, nice. Determine the nature of the roots of the function. Again, very common question. I'm going to draw 3 graphs here. Okay. Let's imagine that's just touching the axis there. Okay. So these are, broadly speaking, your 3 types of root you're going to get. Okay. So here our quadratic crosses. I'll just do it in orange again. It crosses the x-axis twice. Okay. Here it just touches the x-axis once, and here it doesn't. Okay. So here there's 2 roots. Here there's 1 root, and here there's 0 roots. Okay. This becomes important when you kind of go through the course. So right now it might just feel like an unnecessary exercise, but yeah, this does become important when you start analysing data. And to work out the number of roots, we do the discriminant. So b squared minus 4ac. Okay, so it's not the full quadratic formula; it's just a discriminant. Okay, so the full quadratic formula, which is given, minus b plus or minus the square root of b squared minus 4ac over 2a. So that's given right at the beginning. Okay, minus b plus or square root of 4ac, and that's our discriminant value in there. Okay, so again, you don't have to remember that. Just the minute you see the word roots, okay, you'd be thinking about the discriminant. Okay, so what's a, b, and c? So there's our equation there. So I know that a is going to always put, I'll just write up here. So a, b, and c. Okay, so it's going to be 2, 4, and 5. Okay, so b squared, 4 squared, minus 4 times a, which is 2, times c, which is 5. So I've got 16 minus 4 times 2, that's 10, so it's minus 40. Okay, so it's going to be minus 24. So we've got a minus number. Okay, so I said these are the 3 different types. Okay, now when you get a minus number, this is what you're looking at. Okay, you have no real roots. Okay, if you have, this comes out as 0, you've got 1 root. Okay, so that's when it's going to 0, and when it's greater than 0, you get 2 roots. Okay, now the no real roots is because if this number is less than 0, we've got the square root of a negative number, which we can't do yet. Okay, that gets into imaginary numbers, which I think is higher. Okay, so that makes sense. So you can kind of think to yourself, well, yeah, what is it again? What's the rule? Oh yeah, if I've got a negative root, I can't do it, so there's no real roots. If this number becomes 0, this equation would become minus b plus or minus 0 divided by 2a. So if you plus or minus 0, doesn't, you're not going to get 2 different numbers, are you? You're just going to get the same number. Okay, so that's why you're going to have 1 root. Whereas if you've got a positive number, if this is let's say 5 or something, okay, you're going to have minus b plus 5 and minus b minus 5, so you're going to have 2 different numbers, so you're going to have your 2 roots. Okay, so when you see the word roots, always think discriminant, and they give you the discriminant. Okay, so no roots, 1 root, and 2 roots. That's your 3 options. So here we have no real roots. Okay, good stuff.